Hey, this is our video on linear versus non-linear graphs. And we're just going to look at a couple of word problems and we're going to figure out how to put them in a table, write an equation, and graph them. And we're going to read the context first. So here we go. So a koi pond starts with one fish. So that starts would be our initial. Sounds like our B. And the owner adds two fish to the pond every year. So that sounds like our slope. So my equation is 2 added per year, and I start off with, go away, there you go, 1 fish. There's my equation. So let's fill out this table. So 0 years, 1, 2, 3, 4. So I start off at 0 years with one little fishy, and then every year I'm going to add 2 fishies. So I'm going to have 3, then 5, then 7, and then 9. So notice our slope is 2 if we looked at the table with the initial value of 1. And I'm just going to graph this really quick. So 0, 1, 1, 3, 2, 5, 3, 7, and 4, 9. And I know I could keep continuing by going up to over 1, right? Because that's my slope. And I probably wouldn't, put a line through this. This would be a discrete, because we probably wouldn't put like a half a fish. There might be a point where we put 1 in, but we really don't know, so it wouldn't make sense to connect the dot for all those solutions. So we've done that a lot. That was a pretty easy linear equation. So now we're going to look at the next type. This is going to be our first one that we're going to call exponential, and that's the next section that we're going to be working on. And so if you remember, what we just did is this table of value, we're adding or subtracting when we do linear equations, right? So for every 1, we go up 2, right? Well, not always are we adding, sometimes we're multiplying. So an exponential is where you're multiplying your rate in between each unit. And you'll see what I'm saying as we get working on this one. So the koi pond starts with 1 fish. So we still have that starting amount of 1 fish. And the owner doubles the amount, so it's multiplying by 2 every time. So it's not linear. So I'm multiplying, non-linear. Linear is when we're adding or subtracting. Okay, so on year 1, if I double the original from the year back, well, double of 1 is 2. And at year 2, double of 2 is 4. Year 3, double is 8. Year 4 is 16. Notice it grows a lot faster too. So notice as my x changes by 1, I'm multiplying all of these by 2. So non-linear. There's no way I could find a constant adding number that would work between all of those numbers. Okay, so let's graph this real quick. So I have 0, 1, start off with the same amount, and then I have 1, I go to 2, 2 goes to 4, 3 goes to 8. It's like the coronavirus, right? Remember them talking about exponential. I know we're tired of hearing the coronavirus, but if something grows exponentially, then it grows at a very quick rate compared to linear or a straight line. So it blows up, goes up. And then my next one would be 32, right? So if I went to 5, I'd be all the way up to 32, which is off my graph. Okay. So how would I write this? Well, my starting amount, so this equation looks like this. Y is equal to A times B to the X, where A is our starting amount, which is like our B and Y equals MX plus B. B is our multiplier. So if I wanted to write this equation, I started with 1 times my multiplier was 2, and I always have the variable x at the top. So this kind of basically comes down, we don't have a 1 multiplier, so it would just be 2 to the x, and we would just assume that there's a coefficient in front of that being 1. And if you notice, if I plug in 0, anything raised to the 0 is 1, and then 2 to the 1 is 2, 2 squared is 4. So if I plug in any number, I would be able to find my output of fish. So this matches up with this equation. That was our short video. And then go back to your Canvas page, and you're going to do a quick Desmos activity on adding on exponentials.